Okay, so this question is finding the values of a, b, and c where the curves y equals x squared plus ax plus b and y equals cx plus x squared have a common tangent line at negative 1, 0. So just to refresh, a tangent line is a line where if you have a graph, it basically goes and grazes the graph right there, and it touches the graph in exactly one point. So what this is saying is you're not only going to touch the exact same point, that point being at negative 1, 0, so another picture, so negative 1, 0, whatever our two graphs are, say they're like this, actually neither of them will be like that. So they're both positive x squared. So we'll say one's like this picture, and one is like this picture. They would have a common tangent line right at that point. So our first goal is to discuss kind of how do you write the equation of a line. And to write the equation of a line, you really just need any point, which they are giving you right here, and you need a slope. So our first thing is to show that you're going to get this point negative 1, 0 when you plug it into the function. So what I'm going to do is take the functions they gave me, which are y equals x squared plus ax plus b, and we're going to plug in negative 1 for x and 0 for y, and we're going to see what we're kind of left with here. So we end up with 0 equals negative 1 squared plus a times negative 1 plus b. So we're going to get 0 equals 1 minus a plus b. We're going to do the same thing for the other equation. So I'm going to do that on the next slide. So again, from the previous slide, you had an equation that said 0 equals 1 minus a plus b. Now we're going to test negative 1, 0, plug it into the other equation. So we're getting 0 equals c times negative 1 plus negative 1 squared. And we have 0 equals negative c plus 1. So actually, right now, we could actually find c without doing much more work. So we're going to subtract 1 from the other to the other side, so minus 1. And we get negative 1 equals negative c, so c must be 1. So I can actually write the equation of the second parabola right now. So our second parabola is going to be y equals x plus x squared, because the c value is 1. Alright, we're going to be using that later. This equation, however, we're not going to be able to solve for a or b, so we need to add some extra steps here. So the other thing that two tangent lines have in common is not just the point, but also have a common slope. And from calculus, what we've learned is that to find the slope of a tangent line, you need to come up with the derivative of the function. So we're going to take the derivative of each function, and in this first case, we're going to have y prime equals 2x plus a, and the b goes away because it's a constant. And for the second equation, we're going to have y prime equals 1 plus 2x. So these two y primes from our two equations have to be equal to one another in order for these two tangent lines to have the exact same slope and the exact same value. So we're going to set them equal. So we have 1 plus 2x equals 2x plus a. And in this case, the 2x's actually cancel, but not all problems work that way, so just to give you a technique that you can use always, you're now going to plug in your x values. So we have 1 plus 2 times negative 1 equals 2 times negative 1 plus a. So you end up with 1 minus 2 equals negative 2 plus a. In this case, a will be 1. And now we're going to plug a back into our function to figure out what b is. So we have 0 equals 1 minus 1 plus b, and we end up with 0 equals b. So our values of a, b, and c are going to be a equals 1, b equals 0, and c equals 1. And that's basically it for this problem. It's also really interesting to note that if you actually plug a, b, and c back in, you get y equals x squared plus 1x plus 0, and here you had y equals x plus x squared. So they are actually the exact same graph and the exact same function in order to have the same tangent line, same point.